Good evening, Varun. You are very observing the maths class earlier. Before 5 o'clock, did you attend any other class? Yeah. Actually, it is meant for, yeah. Okay. Doesn't matter because it was, yeah, it is not a maths class. It is actually meant for NTSE, National Talent Search Examination. Okay. Right. Today we will see the remaining part of this lesson, that is starting from electric generator. Yesterday we discussed about the Fleming's right hand rule, isn't it? Left hand rule already we have seen about motor rule. Now the right hand rule, which is always called the generator rule. Before going to this deep into this construction working of electric generator, the basic principle you have to understand. What is the principle here we are employing in this generator is nothing but the phenomenon of electromagnetic induction. The phenomenon of electromagnetic induction. It is only employed to produce current for the homes as well as for the industry. In large scale it is used for industry. For homes it is in the optimum level, which is required level. Now in the motor, in the electric motor, we know that the electric energy is converted into mechanical energy. Now it is in the opposite case, the reverse of that. Here the mechanical energy is used to rotate the conductor. Right, mechanical energy is used to rotate the conductor in a magnetic field to produce electricity. Right, this is the opposite of the electric motor. Yeah. Now let us see the construction working. First, before construction, the same thing is there. We have got a powerful magnet and we have got a rectangular coil ABCD, which is called a armature. Right. The only change is, yeah, in the motor we had a split rings. That is, the ring is split into two halves. But here we don't have split rings. Here instead of that, we have got two rings, two complete rings, R1 and R2. That is the only change which you have got. Okay. And there we have got a battery. Here we don't have battery. We are having a galvanometer to find out how much current is flowing through that. Because in exams, many students by mistake, in place of galvanometer, they will drop battery. Isn't it? Battery is only for supplying current, so that the coil will rotate. But here it is the reverse of that. The coil is rotating, we are getting the current. So that mistake we should not do. We have to remember that. Right, here. As usual, this electric generator has got a coil, rectangular coil, which is placed between the between the two poles of a powerful magnet. Powerful, or we can say permanent magnet. Here we say permanent magnet, but generally it is get in between the powerful electromagnet. Right. Now, the two ends of the coil, as I told you already, the rectangular coil armature, the two ends are connected to two rings, namely R1 and R2. Actually, it is not mentioned here. They are called slip rings. They are called slip rings. They will keep on slipping from one to another. So it is called the slip rings. Okay. There it is split rings. Here it is slip rings. But you can simply write two rings R1 and R2. Right. Now, the inner side of these rings, they are made insulated. We know that. Why is it so? Because this current should not flow to this axle. Because if the axle is not insulated, the whole generator will get a leakage of current. To avoid that, the inner side of these rings, you can see that there is insulation. It is well insulated. Right. And there are some brushes, B1 and B2, two conducting brushes are there. And they are kept stationary. They are kept stationary and pressed separately on the rings. Right. You can see that the brush B1 is pressing the ring R1 and B2 is pressing the ring R2. And these brushes, after a long use, they may get worn out. After some times, it may not work. At the time only, they will start changing that. Right? Okay. So, R1, the ring R1 is in connection with the brush B1, and this ring R2 is in connection with the ring B2. Okay, both the rings are pressed against these two rings. both the brushes. Now what happens, let us see. Already told you, they are both the rings are, though they are insulated, though they are insulated, but they are connected to this axle. Do you know why? Do you know why they are connected to the axle? Because the axle is the one which we are going to rotate, so that the coil is going to rotate. So if this axle is rotated, the coil will start rotating. Okay, that is why, because the ends are connected to this rings, so that the ring should be connected to the axle. So when you rotate the axle, the rings will also move along with the axle, so that the coil will also rotate about that axis. Okay, and they are mechanically rotated here. Mechanically rotated from outside. Mechanically means in what way do you say? Mechanically, how can you rotate this? By manually, by hand we can do that. Just like a dynamo in a cycle. When you are pedaling the cycle, it is also a generator. It is also a generator dynamo. But here, for a large scale industries, like for example power plants, you cannot do it manually, but we can do it mechanically. Mechanically in the sense, the moving water is flowing, when it is flowing, when it is dashing against the big turbine like a fan, it is called mechanically rotated. So that fan will be attached to this axle. So along with that, it will start rotating. Okay. So they are rotated from outside, right? And when it is rotated from outside, this coil will rotate inside the magnetic field, in between the powerful. How can a rectangular coil rotate? I told you already. See that this is the coil. Now the two ends of the coil are connected to the rings, two rings, and the ring is connected to the shaft. So when a shaft is rotating, the coil will rotate like this, right? Like this. This is how it is rotating. And we saw that armature yesterday. I showed the diagram how the armature will be inside the motor, So it will have the ball bearing. Yeah, ball bearing will be there. The axle will be there. So along with that, it will start rotating. Okay. Now, Now, the outer end of the two brushes, there are two brushes I said, B1 and B2. These two outer end of the brushes, they have to be connected to the external circuit to draw the current from this. The external circuit is the one which will draw current from this. Once the current is start flowing, it will flow to the external circuit, so that it can be connected to the transformer for power transmission. Right? If it is a domestic purpose, the external circuit will be connected to the regulator. From the regulator, it will be supplied for the different appliances in our house. Now let us see how is it going to function. Now when the axle is attached to the two rings, when it is rotated such that the AB arm is moving upward. You may ask, sir, earlier can it be moved upward or downward, or in which direction we should start from? It can be from any direction we can start. Since we usually count like A, B, C, D, we start from AB. So that it is starting from AB, so that it is moving upward. I am rotating the this axle in such a way that AB is moving upward, so that CD will be moving downward in the magnetic field produced by the magnets. Now we are going to apply the Fleming's right hand rule. What is that? Now, when it is rotated, AB is moving upward, it is nothing but clockwise direction, isn't it? Along the numbers in the clockwise direction. Now, apply the Fleming's right hand rule. The force is in the upward direction. The magnetic field is perpendicular to that from left to right. Now, what is the direction of current? Apply that using your right hand. Keep the first three fingers in such a way that the force is in the upward direction, right? The magnetic field is in the which direction? You just check it out in which direction the current is flowing. You have to keep your finger like this. My middle finger is facing the board, going inside the board. My thumb is upward. My forefinger is in the along the direction of the board. See that this is how the direction of the current. Now AB is moving upward, means the thumb is showing it is moving upward. Direction of magnetic field is shown here. Now what is the direction? Inward, that is it is going inside the board. That means from A to B the current will flow. Is that clear? So the current will flow from A to B and then in the arm C to D. So the direction of current is A, B, C, D. So from A to B, C to D, again in the external circuit the current will flow from B2 to B1. This is what the direction of current in the external circuit for the first half rotation. Have you understood? Yes? Yeah. Now, if there are any large number of turns, as we saw that yesterday in the armature, there are so many number of turns, right? So the current generator in each turn will be getting added up, so that it will give out a large amount of current through the coil. We have got only one turn here, just for understanding purpose, but actually it will have more number of turns to have more currents, right? So here in the first half the current will flow from B1 to B2, that is from A, B, C, D, and externally it will be from which direction? B2 to B1. This is the direction of current. Now after half rotation, that is in the next half, what will happen? The arm CD will start moving upward. That is the first half. This is the actual position. Now we have moved for half. This is one half over. What is the second half? Now earlier AB was here, CD was here. Now one half is over. So the CD has come here and AB has moved there. That means in the second half, the arm CD starts moving up and AB moving downward. Right? The position is same, but only the arms have changed. Okay, same position only, one half, 180 degree. We have rotated 180 degree. 180 means nothing but half rotation. So the arm CD will now start moving upward. Arm AB will move downward. Now as a result, what will happen again? The direction of current in both the arms will change, because we are changing the coil, orientation of the coil. Direction of coil is changed. That is, the direction of force is changed. So due to that, what will happen? The current will also be changing. So that the current will flow from DC, again DCBA, in the opposite direction, because the arm is now here. So DCBA. So what will happen to the direction of current in the external circuit? Earlier it was from B2 to B1. Now it is from B1 to B2. So like this, after every half rotation, the polarity of the current in the arms changes. Due to that, the current will also be keep on changing. So that you can see that the galvanometer will show deflection on opposite side. First half rotation, left hand side means the second half rotation it will show in the right hand side. That is right side, right direction. Yeah. See that? You have to keep your right hand first. Keep the first three fingers of your right hand mutually perpendicular. Right? Try that. Now, you keep your finger in such a way that you are facing that board. If it is notebook or if it is your monitor, keep your middle finger keeping that on the monitor. Your middle finger should point on the monitor. Keep your middle finger on the monitor. Right hand. So how I am standing? I am standing parallel to the board and I am shooting like this, isn't it? This way you have to keep. If you are sitting like this, you have to keep your finger to your right side and then keep like this, so that you will understand. Now I am keeping here. Okay. Now this is the direction of movement of the conductor. Okay. So see that this is the conductor. Okay. Now the conductor is here. This is the direction of magnetic field. When the conductor is moved upward, this is the direction of motion. Since the magnetic field is like this, from here to here, this is pointing out the direction of magnetic field. Now my middle finger is pointing towards the board, that is going inside the board. So that is the direction of current. If it is inside the board means nothing but this is inside the board. so that the current is from A, B, C, D when it is in the first half rotation. Now after half rotation, when the CD comes here, the direction of current will be changed because it is from CDBA. So in the external circuit also, current will flow from, first it is B2 to B1, now it will be from B1 to B2. So this is how for every half rotation, the current, direction of current will be keep on changing. Now, such kind of current where the direction after equal interval of time is changing, that is called the alternating current. It is called an alternating current. What is an alternating current? Means the current which changes the direction after equal interval of time, you can say. See, for example, I have drawn a graph here by taking time on the x-axis and the current in the y-axis, direction of current, or you can say, yeah, after half rotation, this is one half rotation. See, in the beginning when it is showing 0, the coil is horizontal. That is, the armature is along the direction of magnetic field. Okay, angle between the coil or the direction of flow of current. See that this is the direction of flow of current and the magnetic field. Both are in the same direction. When there is no movement, okay, there is no current. Now when it is start rotating, you can see that the current is slowly increasing. Now when the coil is perpendicular, to the direction of magnetic field, you can see that the amplitude, maximum current is there in the positive direction. Again when it is moving in the opposite direction, the current is slowly decreasing and becomes 0 when it is again parallel to the magnetic field. Again in the next half rotation, this is going down. This arm is going down. So it is moving in the opposite direction. The current is still increasing in the negative direction, we can say, and reaches the maximum value in the negative direction when it is coming perpendicular to the magnetic field. Again after one rotation, it is coming to the exact position. So right from here, when it is complete one rotation, we can say one full wave like this. Okay, from here to here, this is full wave. This is what we call as sine wave, sinusoidal in nature. When you go to higher classes like 12th standard, you understand that the current, AC current is represented like this. This is called as sinusoidal nature. Okay, sine wave, simply we say sine wave. So 0, maximum, 0, maximum, 0. Okay, so the maximum is called, this is called amplitude, and this is called one cycle from here to here. That is from here to here, this is called one cycle. Okay, so this device is nothing but called the AC generator because it is generating alternating current, a current which changes the direction after equal interval of time, or we can say periodically. Periodically, if the direction of the current changes, that current is called an alternating current. Now I will show you a video which will help you to understand how the AC current is created when the coil is rotated in between the powerful poles of the magnet. Okay, now look at that. Now you see that here it is rotated in the anti-clockwise direction. Doesn't matter. When you are rotating in the clockwise direction, it will start from 0. When you are rotating from anti-clockwise direction, it will be starting from the negative maximum. That's all. See that? Again, I will play that. You can see. Once it is rotated, you can see how the coil external. This is the external circuit. You can see that these are the two carbon brushes, and these are the two rings, R1 and R2. And they are connected here externally. The current is flowing to the external circuit like this. Here it is connected to the appliances. As it rotates in between that, you can see the current. This is nothing but North Pole and South Pole. It is not blue color, sir. To mention the usually when you take a bar magnet, the red color will indicate the North Pole and the blue color will indicate the South Pole. It is the where is the other blue color here? This one you are asking? That is called AC current, sir. It is not wave-like thing. It is AC current. Yeah, that is called the AC current. Yes. This wave-like thing is nothing but, yes, current only. It is only to show you, this animation is only to show you that the current is created like that. But actually current will not be flowing from this to this without any contact. It is only to understand how the AC current is changing with respect to time. Okay, the direction is changed, To understand that only you can see that as it rotates, the direction is changing. To understand that only, see, as it rotates, the direction is changing like a sinusoidal wave, sine wave. So for that only it is given like this. Okay, actually we have to give connection, wire connection, so that we will get the current flowing in the external circuit. Right. So this is what about a AC generator. Now you can get this as a direct current. From this same idea, generator, you can get DC current also. How is it? Along with that, earlier in the motor, we used this split rings, isn't it? So in the same setup, we are going to have split ring also. If you use the split ring along with this arrangement, you can get the DC current also. Because every time the split ring will be in contact with the brushes, so you will keep on getting the current in the same direction. Okay? So all the time if it is in contact, you will get the current in the external circuit. That is called a unidirectional current. Okay, and that kind of generator is called a DC generator, which produces direct current. That means it will not go to the negative part. We have seen the graph, we have got in the opposite direction. The direction is changing. When you are using the split rings, that is split rings, you will have only the unidirectional. Only in one direction the current will be there. That means it will be like this. Along with that, you can see that the current will be like this only. This part will not be there. So you have only unidirectional. So this is called a unidirectional current. Right. Okay. Now you should understand the difference between this direct and alternating current. Where will that is in the opposite direction. I said no. From A, B, C, D, in the arm direction, it was moving. How will it? Put your question properly. Unless you ask properly, I cannot give you. Okay. Okay. Have you ever seen a generator in a house? The Honda genset is small generator. Yeah, we'll have the generator, you'll put petrol and it will start rotating. So in the generator, generally, once you start that, the current will be there. Yeah. It is connected to the external circuit like household appliances, So in that, it will be flowing. The external circuit, the current will be flowing. If it is not connected, where will the current be? That is your question. If it is not connected, sir, though the coil is rotating, where will the current be? A current is nothing, after all, nothing but the energy of the electrons, to move in a particular direction. The EMF we say, isn't it? So they cannot flow. It is something like, you tie with the elastic and tie it with the wall and keep on running. Where will you go? Somebody is holding you. If only you are left, you will start moving forward. Otherwise, you will be running in the same place. It is something like that. The electron cannot flow, isn't it? They cannot take the energy. They cannot flow in one particular direction until such time they will be accumulating. They will be there only. They cannot move. After all, current is nothing but flow of charges. Unless the charges are flowing, the current cannot flow. Like a battery, once you connect the battery only, the current will take the energy and complete the circuit. Otherwise, the electrons will be in the same place, that is in the battery only. It is something like that. Okay. Now let us understand the difference, basic difference between the direct and AC current and DC current. This is one of the important questions we have to understand. There, the direct current always flows in one direction, which is represented as a straight line, you can see, without any change. It will not vary with respect to time. It will be unidirectional, we say. Whereas alternating current is, as we have seen the graph, it will be reversing or changing the direction periodically. This is one of the important difference, basic difference between AC and DC. Direct current is always flowing in one direction, unidirection. Whereas alternating current reverses its direction periodically. This one point you have to understand. Later we'll add one more point. Now in India, most power plants, power stations, hydroelectric power station or atomic power station or thermal power stations, they are all constructed on these days to produce AC current only. Right? In India, we have got a specific current which is calibrated as 50 hertz, the frequency of change, the rotation we say. Frequency is nothing but number of rotations, number of cycles per second, right? That is usually 50 hertz. So you have to remember that this is one of the multiple choice question. The frequency of AC used in India, it is 50 hertz. Is there any other frequency which is used actually? Suppose if we take like foreign countries like US or Japan, there they are using 60 hertz. The frequency may be differing. But in India, in our house, what the current we are using has got a 50 hertz. This you can notice, suppose if you have got a tube light in your house, there is a choke in the middle. On the choke it may be written. Or if you take a fan, there may be a label on the fan which will indicate that how much voltage we have to use, how much frequency of AC we have to use. Okay, that will be calibrated as 220 volt 50 hertz. That is the usual current which we use for domestic purpose. Okay. And another one is the advantage is here. Greatest advantage of AC, alternating current, is that it can be transmitted over a long distance without much loss of energy. Now, how can you understand that? Suppose if we take an ordinary dry cell which we are using for torchlight. If you connect the small bulb with that wire, you know that the bulb will start glowing. Instead of the small wire, if you take a long wire from your bedroom to say portico, you take a long wire, or say instead of 10 centimeter wire, you take 1 meter wire and connect the same bulb and same battery, you can see that the brightness will be reduced because the DC current is traveling such a long distance. By the time, because it is affected by the resistance offered by that conducting wire, right? So due to that, what will happen? The power will be slowly reduced, and by the time it reaches the bulb, the energy would have been lost, so that the bulb will be glowing only with a little brightness. But in AC, it is not so. It can be transmitted over a long distance. Even from Delhi to Chennai, it is possible. How is it possible? Because here there is a possibility of changing the voltage and changing the current. You can increase the voltage and decrease the current, so that you know that voltage is nothing but the EMF is nothing but that is only is pushing the electrons, like a water pressure, how the water is moving. That pressure is nothing but created by this voltage. So if you increase the voltage, the electrons can be pushed very fast for a long distance. It is something like you keep on pushing that, so it can travel for a long distance. Right? That is why you would have seen that in the nearby the city where the power is transmitted, we have got a power station, that is EB station is there, where we got a very big transformers. Or if you go to railway station, if there is a transformer, you can see there the voltage what they are using is nothing but around 44,000 volt. Not what we are using in the house is only 220 volt. But there in the production center or nearby hydroelectric power station, if you see, it is nothing but like 44,000 or 55,000 voltage. Such a high voltage, it will be stepped up. What the current they are producing at that power station, the voltage will be increased so that it can travel such a long distance. Once it reaches the city, there will be another transformer which will step down from 44,000 to 440 volt. Again, when it reaches for domestic purpose, we will reduce that to 220 volts, so that will be utilized for domestic appliances. So that is the greatest advantage of AC over DC. In DC it is not possible. To convert this voltage in DC, it is highly complicated. We have to have an alternator, there is a converter, again we have to, different components we have to use. It is very difficult to convert this power for a long distance, to take the power or take the DC current for a long distance. There will be much amount of loss of energy. So this is the great, we have to understand that the important advantage of AC over DC is that electric power can be transmitted over a long distance without much loss of energy. This is one of the important points you should remember. After this, we have produced electric power. Now we know how to take that from a power station to domestic usage. There we should know how to use that current properly using proper circuits, because if the circuits are not proper, what will happen? You will meet with loss of power, which will be a great loss for the production center also. So for that, how the domestic electric circuit should be designed, that is the next part of this lesson. Here we know that how do we get the power supply from the power station, right? In our home, we receive power supply through three different parts. That is through a main board is there. We call it as AC mains. This is main board, right? Through this main board only we get the power supply. We know that where there will be a motor of, that is meter will also be there, and plug carrier will be there, isn't it? And this power is received through two different categories. One is using underground cables. In cities and all, we cannot have the power cable moving across the streets. So there, where the transport is there, vehicles are there, people are moving, we cannot have the bare wire which is moving around there, isn't it? So in such cases, they will have this powerful cable which is going under the earth, which is called the underground cables, right? Which is insulated, well insulated. It cannot be damaged very easily. Such a well insulated underground cables will be there. But in other places, we will have this overhead post. Nearby, there will be a post, through that the aluminum wire, that wire will be coming there. From that only, we will get the power supply. So through the main board, from underground cables or overhead posts, we will get the power supply. Now, in the house, you would have seen that we are usually, the power cable will have two wires. The red one and the black one. Generally, it is indicated with these two colors. But we are using different colors, doesn't matter. But general concept, the conventional method is that the red wire is called a live wire, positive wire, where the current will be flowing. From the transformer, the current is flowing through this red wire. That is the live wire we say. The next black wire is called a neutral wire. After the current has flown through this appliance, the return current will flow through this neutral wire, right? After losing the energy, the electrons are flowing in the opposite direction, no? So that is called the neutral wire. And I have already told you what is the calibration, what is the, how do we express this current in India? It is 220 volts, 50 hertz. So this 220 volt is nothing but, the voltage is nothing but, we know that potential difference. That is the potential difference between this live wire and neutral wire is nothing but 220 volts. So that is the number you have to remember. Yeah, potential difference. Now how the circuit is made in a house. Usually we have, in the main board we have got a meter board. Before the meter board there are main fuse. These are called carriers, which will carry the current, and with the main fuse. What is the fuse? After this we will learn. So through this only the current will flow to the meter board. From the meter board there will be a main switch, and this main switch is for controlling the current. If you want to have any repair work in the house, or if you want to make any changes in the electrical circuit, you have to switch off that so that the current will be, flow of current will be stopped. For that the main switch is there, and from the main switch it will be going to the line wires. These line wires are nothing but distribution part. That is, for different rooms or different appliances we are going to have this line wire. So from the line wire we are going to have two different circuits, separate circuits. In each room we will have different circuit. In some rooms we may have AC, In some rooms we'll have only lights and fans. In some rooms we'll have heaters. So we are going to have two different circuits. One is with the high power rating, which is called a high power rating, which means this wire should have more capacity to have current of 15 amps. The strength of the current carried by these wires should be more than the usual one. The usual one, which is having the fans or bulbs, can have only 5 amps. Because you know that when the current is flowing, according to Joule's heating law, it will generate heat. Right? So if it is generating heat, the wire should have the capacity to withstand the heat. Otherwise what will happen? It will cause damage. The wire will start melting and will produce resulting in short circuiting. So for ordinary appliances which is low power rating like fan or bulb or tube lights, we should have 5 amps wire. And for higher power rating like heater or AC or microwave oven or any other motors, those should be connected with the 15 amps high rating power circuit. So these are the two power separate circuits we should have at home. Okay. And the next important concept in this electrical wiring is the earth wire. The earth wire, apart from this black and red, and this earth wire is given green color. Green actually means that earth, you know that. Green earth, isn't it? The green color is actually indicating the earth wire, which is connected to a metal, and that metal will be kept deep inside the earth near the house. You would have seen that near the meter board, a wire will be going to the earth, and if you see that wire will be connected to a metal rod or plate, long like a crowbar. Gatabar and solumale, crowbar, long rod, iron rod, which will be kept inside the soil. Right? And that is called the earth wire. Now, why is it? What is the need for the earth wire? Right, and this is used as a safety measure. This earth wire is usually have the low resistance path, which will be a perfect conductor like copper wire, right? And this is used for safety measure to safeguard the appliances like electric press, like iron box, toaster, table fan, refrigerator, all those which have got metal body. These metal bodies, if there is a chance of coming in contact with the current, what will happen? When you touch that, you will have a bad shock. So such type of all the electronic or electric appliances which has got metal body should be given this connection, the earth wire. If they don't have this metal body, if they have got only plastic body, we need not worry about it, because we are going to have in contact with the current. So all the appliances which has got metal body should definitely be given this green wire connection, earth connection. So what is the use of this? It is providing a low resistant conducting path for the current. When it is connected to a copper wire, usually the green color wire, earth wire will be copper wire. So copper is a good conductor of electricity. So the current will easily flow through this copper wire. So if there is any leakage when you are making the circuit in the domestic, in the houses for domestic purpose, if there is any leakage when you are using an iron box, for a long period it would have worn out. So the metallic body, what will happen? They will have a leakage of current. At that time, the current will easily flow through this earth wire, so that it may not give a severe shock. So that also it will protect the appliances from getting damaged. That is why we are using this earth wire. Now this is what the schematic diagram of the domestic electric circuit. This circuit diagram you have to remember. Okay. So usually what is there? We have indicated already. This is the electricity board with the fuse. Okay, and there is a meter. And from there, live wire and neutral wire will come there. Only two wires we are using. The third wire will not come from the transformer or from the outside power supply. We have got only two wires, main wire and the neutral wire. Now from the electricity meter, we will have the distribution center, distribution box containing a main switch. The switchboard is there, and for fuses for every connection. We will have different lines for different rooms. So for everything, we will have a fuse. If there is any damage, the fuse will get broken, get damaged, so that the current flow will be stopped. For that we are using here. and from that we'll have a different appliances connected to each line. And from each appliance, you can see that from each part we have got a green wire which is connected to the earth. From each appliance you can see, from each plug point we call this as a plug point or any switch where we are inserting the appliance. 3 holes are there. One hole is for main and another hole is for neutral. The third one is for live green wire, that is earth wire. Okay, the iron box will have 3 sockets. You know the 3 pins will be there. Wherever 3 pins are there, they have got a earth. That kind of appliance is very safe for using. If it is not having 3 pin, if it has got only 2 pin, and if the appliance has got a metal part, then it is very dangerous to use. Sometimes you may get a shock also. Okay, so this is the indication of the domestic schematic diagram for domestic electric circuits. Now in each separate circuit, I said that we can have a different appliances can be connected across live wire and neutral wire. But each appliance should have a separate switch to have on off or flow of current, to control the flow of current. For example, I have given a small diagram you can see here. We have got a same board, right? Only one board socket is there. From the same socket, this is like a switch board. We have got 3 switches here. From each switch I have got one appliance connected across. So this is the switch. See that? From here the live wire is connected across all the 3 uniformly. The current is flowing from all the 3 sockets. But what is different? The neutral wire is different, because when I switch on that, the current will flow from here and it will go to the bulb. From the bulb it will go to the neutral wire, and the neutral wire is separate. Right? And again the second switch is there, it is connected to the fan. Only the neutral wire only we are making change. All the live wire is connected in the same line. In the switchboard also, if there is a chance, if somebody is building a new house nearby, you can just visit when they are giving the electric connections. You can see the back side of the switchboard, how it is looking like. Or you can ask your daddy to show this by opening this box socket, electric socket, and you can, by switching off the main switch, you can ask your daddy to remove that and show that the back side of the switch, how it is connected, how each electric appliance is connected. It's very practical method of understanding. So this is how it is connected, right? Now, in order that each appliance, why should be connected? It is like what we call it as a parallel connection. When you are connecting the appliances parallelly, the current through the voltage current, that is the voltage through that will be same. Potential difference will be same, right? So if it is series connection, what will happen? The bulb will be connected to the fan, fan will be connected to the TV, and TV only will be connected. One switch is enough for series connection. But what we have got 3 switches, so that all the 3 are connected across 3 switches, which is called a parallel connection. In the parallel connection, the potential difference will be same. Okay, right. The next comes the important part of this, final part of this lesson, which is called the electric fuse. Electric fuse is nothing but, generally we say, in our house also, the bulb, organ bulb, gundu bulb solluvom illaya. That bulb, we say, if it is not glowing, fuse poidichira appdinu solluvaanga. There is a filament inside, If the filament is damaged, we say it is gone, damaged, isn't it? Similar application only we are using that for safeguarding our electrical appliances. It is for all the domestic circuits, this electric fuse is playing a vital role. It is, what is the use of that? It is used to prevent the damage to the appliances and the circuit due to overloading. Overloading, you know that when overloading is occurring, what will happen? The fuse will prevent the flow of current. How is it going to prevent? Let us see. What is overloading? How is it going to prevent? And what is fuse? First of all, let us see. Usually the fuse is made up of an alloy. I'll tell you. By learning this part, you will understand that. First, you understand that the fuse wire, there is a special wire we are using as a fuse. And that fuse wire is nothing but an alloy. It can be a metal or alloy of 37% lead and 63% tin. This information is not in your book. It's an extra information you have to understand. 37% lead and 63% tin. Okay. And because these metals have got a very high resistance and low melting point, very low melting point, that means when the high current is flowing, they will easily start melting. Okay? And this fuse should be connected in series with the device. If the device is there, the current should flow through the fuse only. Through the fuse only the current should flow. That is called a series connection. Right? Now, what is overloading? You asked me. Let us see what is overloading. This overloading will occur when the live wire and the neutral wire, when they are coming into contact, direct contact. We have seen that red wire and black wire, isn't it? Sometimes they may get damaged due to different reasons, like heating effect, Joule's heating effect, or when you are using an appliance which draws more current, right? High rated power appliances. So when you are using that, it will draw more current, so that the wire will start melting. At the time, they will get in touch with each other. So what will happen? This is called overloading. Okay, when the live wire comes in contact with the neutral wire, that will lead to overloading. Or sometimes the insulation, what I said, you can see that diagram here. The insulation over that wire, when it is damaged, or if the appliance itself is fault. You know that some of the appliances will have coil. If the coil is getting damaged or the appliance has got damaged inside, that will lead to overloading. In such situation, what will happen? Due to that overloading, the current will be abruptly changing. It will be started increasing. High current will be flowing through that. Usually, the current which we are using in our home, I have mentioned that already, 5 amps. 5 amps is the current which we are using. 5 amps, 50 hertz, 220 volts. These are the three numbers you have to remember. 220 volt, 5 ampere, and then 50 hertz. That is the domestic electric supply. So, when the current is abruptly changing, abruptly increasing, this is what we call as overloading. This will lead to short circuiting. Short circuiting means when these two wires, when they come in contact with that, they will have a spark. It will produce fire. Sometimes even the fire accident will be due to this overloading or short circuiting. This short circuiting is nothing but you can also try. If you take the small battery, the torchlight battery, take the two wires, connect that, and try to touch the two wires, positive and negative. What can you see? You can see the sparkles, isn't it? So that is nothing but short circuiting. Now, when you are using this electric fuse, that will prevent the electric circuit and appliances from damage caused by unduly high current or overloading, by stopping the flow of current. Right? You can see that we have got a fuse carrier. We call this as fuse carrier. Here there is a fuse wire which will be kept in the middle. Right? The two ends of the circuit. If suppose we have got an appliance here, the one end of the live wire will be connected, the other supply will be here. So the current will have to flow from this fuse wire only to the appliance. In such a way it will be connected in series. So these are all the different format of the fuse wire. This is called a fuse holder. Right? This is the fuse carrier and this is fuse holder. The fuse will be in between these two. So you have to insert it so that the current will flow through that. Right? Now, I've told you that this fuse wire will have a low melting point. So, the Joule's heating that takes place in the fuse melts the wire to break the electric circuit. That is, when high current is flowing, the high current will produce high amount of heat, and due to that heat, Joule's heating effect, the fuse wire will get broken, melt away. So, when it is melting away, the circuit flow of current will be stopped. Right? And similarly, what is the possible case for overloading? I said already, when live wire and neutral wire come in contact, there may be overloading. And there is another possibility that it can be due to an accidental hike in the supply voltage, where the voltage is produced at the production center. There itself there is a possibility. Even in the wires which is carrying current outside, due to wind also they may come in contact. So when they are coming in contact, the 220 volt will become 440 voltage. So at the time only, we may notice that the domestic appliances will get damaged if the earthing is not done properly, or if the fuse wire is not properly used, all the electric appliances will get damaged. They will even burst out due to the high flow of current. So that is also another possibility of overloading. And sometimes this overloading may be due to the usage of too many appliances in a single socket. For example, you got a spike buster which you are using for computer, like a plug point, In the same plug point, if your sister is using an iron box, if somebody is using a refrigerator, and you are using a system, computer, desktop, so what will happen? Too many appliances you have connected in this single socket. So within few minutes you can see that the socket will be burnt out due to the heat, flow of high current. So that will also lead to overloading. So three possibilities we have seen for overloading. That is another question. What is the different causes for overloading? When a live wire come in contact with the neutral wire, and it may be due to accidental hike in the supply voltage, or when too many appliances are used in a single socket. So these are the three reasons for overloading. Now I will show you one video which will help you to understand how the fuse is working. Right? Here you can see that this is the actual fuse. You would have seen that in most of the electronic equipments, inside the TV, inside a computer, CPU, or in most cases where we are using it as a safety measure. You can see that this is the 5 amps fuse. There are different rating of fuse also. So that it depends upon what kind of appliance you are using. Now look at that, I am playing the video. The current is going to flow from these clips. 2 clips are there. You can consider this as live main wire, and this is the neutral wire. The current is going to flow through that. You can see the ammeter here, which is showing the flow of current. As the current increases, what happens to the fuse you can see now. Look at that carefully. Now the current is here. Slowly it is going to increase now. When it is increasing, look at that wire inside, the fuse wire inside. What is going to happen? Now it is slowly increasing from 0 to 2 ampere. Now you can see that it becoming red hot. After that it reaches the maximum heat, maximum current, so that it cannot withstand that current, so it is getting cut. The circuit is broken now. So no current will flow through that. So this is how the fuse wire is working. Very simple method of or application of Joule's law of heating. Okay. So this is what the last topic of that lesson. So we have got some revision questions. So if you want, we can proceed further for revision of the questions which is found in your textbook and other extra questions. Or we can wind off. Tell me, shall we proceed further for a few more questions? Yeah. This already we have seen. What is the principle of electric motor? Yeah. The motor, it is based on the Fleming's left hand rule. An electric motor is based on the principle of Fleming's left hand rule. This is the important point you have to remember. And the additional point, it is based on the fact that when a rectangle coil is placed between the magnetic field and the current is passed through that, a force acts on that, due to which the coil is rotating continuously. This is the principle of the electric motor, which is very well known to you. And the next one, what is the role of the split rings? Already we have discussed. The split ring is acting as a commutator, that is, they play the role of reversing the directional flow of current through the coil. Isn't it? So this is also one of the easiest question. This word commutator and reversing the direction of current. These are the two important points you have to underline. The split rings acts as a commutator, and that is, they play the role of reversing the direction of current in the coil. And the next one is the principle of electric generator. We know that it is based on the principle of electromagnetic induction. Electromagnetic induction, according to which an EMF is induced in the rectangular coil when it is rotated in a uniform magnetic field. You should not say simply it is based on the Fleming's right hand rule. Fleming's right hand rule gives the direction of current. But what is the principle here? It is based on the principle of electromagnetic induction. This is a very important point. Okay. So an EMF is induced in a rectangular coil when it is rotated in the uniform magnetic field. This is the expansion of this one. Actually, if you write this one, this is enough. But we are adding some more points to understand what is electromagnetic induction, according to which an EMF is induced in the rectangular coil when it is rotated in a uniform magnetic field. That is the principle of a electric generator. And what is the different sources of direct current? This is the another question. When you are talking about direct current, first of all you should remember the DC generator, and then the solar cell, and the dry cell which we are using for torchlight, the dry cell, and the car battery. They are all producing the direct current. At least 3 points you have to remember: DC generator, solar cell, and the dry cell. Dry cell, solar cell, and DC generator are the sources of direct current. And what is the sources of alternating current? AC generator, first of all AC generator, and hydroelectric power plants, hydel power plants, or simply we can say power plants. Power plants in the sense it can be hydroelectric or atomic or nuclear, it can be anything, but all the power plants are producing alternating current. So AC generators, power plants, and then car alternators, and then bicycle dynamos. The bicycle dynamo is also producing AC. Because of the rotational effect between the magnetic field, the coil is rotating, it is producing the AC current. So these are the sources, right? At least 3 points you should remember. The next one, the AC generator, we have already seen that how the induced current is changing, right? Whether it is for 1 revolution, 1/4 revolution, 2 revolution, or half a revolution. That is the question. A rectangular coil of wire is rotated in the magnetic field in the AC generator. How the direction of the current is changing for every half rotation, we know that. In the first half rotation, positive. In the second half rotation, isn't it? Yes or no? For every half rotation, you should remember that. Yeah? Next. This is another question, important question, a practical application. 2 safety measures commonly used in electric circuit and appliances. Safety measures for safeguarding our electrical appliances. What are they? 2 are there. One is, first of all, you should remember that the first one is provision of electric fuse. This is the first safety measure. The second one is proper earth connection of metal bodies of electric appliance. Okay? Proper earth connection and the provision of electric fuse. These are the 2 safety measures. Can you tell me one more safety measure which we have learned from this session? Can you add one more with this? Let us test your knowledge. You add one more safety measure with this one. No, you can add one more. It's only require a little bit of thinking. I'll give you one clue. If you remember the domestic electric circuit, you can give that point. Domestic electric circuit. Different appliances. This is the clue. Or one more clue I give you. Heater, fan. No, that is for overloading. The first point which I have told is exactly correct. We have to give separate circuit for high rated power, high rated electric appliances. By using, third one we can say, by using different circuits for high rated and low rated appliances. Do you understand? Using different circuits for low rated and high power rated appliances. So that is also a safety measure, isn't it? Because if you are using only one line for same different kinds of high rated power supply, that will also be a dangerous one. So that is the third point you can add. Like this, you can only think so that you can, but this is the basic one. Provision of electric fuse and a proper earth connection. These are the basic safety measures that we have to provide in the electric appliance. The next one is the problem, simple problem only. An electric oven of 2 kilowatt power supply, power rating is operated in a domestic electric circuit which is having 220 volts and that has a current rating of 5 amps. What result do you expect? Explain. So domestic, in the usual way, what we have got the circuit connections in a home is carrying 220 volt current and which is having a rating of 5 amps current. So they are asking if you are using a high rated oven, electric oven with a 2 kilowatt power supply. The power of the electric oven, that is my oven is 2 kilowatt, 2000 watts. If you are using this, you know that you tell me that whether it is low rated power circuit or high rated power circuit. They say that the oven is connected to the circuit. Is that circuit power high rated or low rated? High power rated or low power rated? Exactly, low power rated. So definitely what will happen, you can understand now. We have got 5 ohms only, low rated, low power rated, but the power of the oven is very high. Definitely what will lead? Let us see first. To understand that, though the circuit is able to carry 5 ohms, yeah, exactly, overloading will occur. Let us see how the overloading is going to occur. Now we will calculate by using this formula, power, we are going to calculate how much current will be drawn by the electric oven. Okay, to understand what is given here, first we will take, power is nothing but 2 kilowatt, 2000 watts. Kilo means 1000. So 2 kilo means 2000 watts. And what is the voltage? It is given 220 volt. 220 volt is given. Right? What is the current rating? 5 amps. This is the given data. Now let us find the solution. By using that, what is given here, power, if there is a formula that power is equal to V into I, P is equal to V into I, right? That is 2000 is equal to voltage is 220 and I only we are going to calculate. How much current is going to draw, we will calculate. So from this we can take that on the other side, 2000 by 220. So if we cancel that, 0, 0, we will get 200 by 22 which is nothing but around 9 amps. Okay, 9 ampere. This is the current which is drawn by the electric oven. Okay. So the circuit can carry only 5 amps current, but the electric oven is going to draw 9 ampere current. Okay. So what will happen, as you said, it is nothing but overloading. So due to this overloading, what will happen? The electric fuse will melt and the circuit will break due to overloading. Provided, if you have taken the safety measure in a house, if there is a socket which is carrying a fuse, due to the high current drawn by the electric oven, the fuse will get broken and the current will stop flowing. But if the circuit is not provided with the proper fuse, what will happen? It will lead to overloading and cause damage of the circuit and also the appliance. The appliance will also get damaged or the circuit will also be burnt away. Right? So these are the possibilities. These are the two possibilities we can expect due to this overloading. Yeah. Have we noted down? Okay. The next one, already we have discussed about that. What precautions should be taken to avoid overloading of domestic electric circuit? To avoid overloading, what is the safety measure we have to take? So, the first one we know, too many appliances should not be connected to a single circuit. This is the first point you have to note down. Too many appliances should not be connected to a single circuit. And the next one is, the electric wires with proper insulation should be used. You know that if it is not provided with ISI mark, the insulation may not be uniform throughout the wire. In some places the insulation may be very thin, in some places it may be thick, due to the heat produced by the current in the circuit wire, the wire will get damaged. So the electric wires with the proper insulation should be used. That is the second point you have to remember. The third point, very important point, use of an electric fuse avoids overloading of domestic electric circuit. And finally, which you told me the answer, separate circuit with 15 amps should be used for high power rating appliances. These are the 4 important points which are considered as the precautions to avoid overloading. Okay, in the previous problem, have you noted down the calculation part? How did you get the 9 ampere? Did you note down that? Have you noted that? Okay then. Because this point is very important, because how we are calculating this 9 ohms, this is very important. Okay, that is why I asked. Okay, the next one, list the method of producing magnetic fields. How to produce magnetic fields? What are the different methods? Right, we know that by using a permanent magnet we can produce a magnetic field. By passing electric current through a straight wire or a circular coil, we can produce magnetic field. Or by using an electromagnet also we can produce magnetic field. So permanent magnet, by using electromagnet, and or by passing electric current through the straight wire or circular coil. All the 3 will produce magnetic fields. This is another 3-mark question. Now, what is the force experienced by a current carrying conductor placed in a magnetic field largest? When it is largest? We know very well. When it is perpendicular, this is the important point. When it is placed perpendicular to the direction of magnetic field. The force experienced by a current carrying conductor placed in a magnetic field is largest if the current conductor or current carrying conductor is placed perpendicular to the direction of magnetic field. That is, the direction of current should be like this, or the magnetic field should be like this. The current direction of current should be like this. So that when it is perpendicular, then this is field, this is current. So it is maximum. So I can say force is maximum. Diagram you have to remember, that's all. Okay, so the conductor should be placed perpendicular to the direction of magnetic field, so that the force experienced by that will be maximum. Next. This is the last question. Imagine that you are sitting inside a chamber. For this question you are going to answer. Though I have given an answer, you just have to show me how you are getting this answer. You are sitting inside a chamber room with your back to one wall. Your back is facing on one wall. An electron beam is moving towards from your back side to the front wall. From back wall to the front wall. And it is getting deflected to your right hand side. Getting deflected to your right hand side. What is the direction of magnetic field? That is the question. What is the direction of magnetic field? So, how will you find out? Yes? How will you keep your hand, left hand? Tell me. Fleming's left hand rule only. The answer is vertically downward. I have given the answer. How will you keep your hand? The electron is moving from back to front. See, from your stomach, for example, through your stomach. And after that, it is getting deflected to your right hand side. The direction of force is given. You know the direction of current. Now tell me, how will you keep your left hand? You are, after doing some tricks, like Ravichandra Ashwin, your hand will become like this. Too many trials. Keep like this. Now try. Keep like this and try. Shall I tell you? You find it difficult, no? Still you are not God. No. What the way you are keeping? No. What the way you are keeping the hand is wrong. No, it's wrong. No. No, how? Tell me. You show the hand, tell me. Keep your hand and tell me properly. I want you to show me how you are keeping the hand. Then only it implies that you have understood. I'll give you a clue. The direction of beam is like this. Okay? What is the direction of current then? Electron is moving like this. Current direction is? Opposite. That means pointing towards you. So, which finger will, front to back. Which finger is indicating current here? The middle finger. The middle finger. Okay. So, you have to put your middle finger to your stomach. Okay. To your middle finger towards your body. Okay. To your stomach. Now, your thumb should be on the right hand side. Your thumb should be on the right hand side. Now see that I am shooting myself like this. Not like this. This hand should be like this. Your thumb should be on the right hand side. Keep your hands downward. See, I am showing you like this. This middle finger is pointing my stomach. Okay? And the thumb is on your right hand side. That is how. This way, that way. That way, exactly. Now you see the forefinger. Forefinger is pointing downward, Very difficult only. Okay. For this you have to be a very good spinner of cricket ball. Then only you can keep your finger like this. See that? Now this is how you have to find out. Okay? Exactly you got. So the left hand side your thumb is showing. The middle finger is pointing towards your current direction and it is magnetic field. That's all. Great. Okay, with this we'll end the session and meet in the next class, right? Yeah.